If you are getting started with modern technology, you have probably heard the terms artificial intelligence, machine learning, and deep learning used interchangeably. But are they really the same thing? Let's clear up the confusion with this simple relationship overview. Think of these three concepts like a set of nesting dolls, where one fits perfectly inside the other. The largest outermost circle is artificial intelligence, or AI. This is the broad vision of creating smart machines capable of mimicking human behavior. Inside AI sits the next circle, machine learning, or ML. ML is a specific branch of AI that gives computers the ability to learn from data without being explicitly programmed. And at the very center, the smallest, deepest circle, is deep learning, or DL. Deep learning is a specialized subset of machine learning that uses massive artificial neural networks to tackle highly complex problems. So, to summarize the relationship, deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. As we move from the outside in, the technology becomes more specialized, more complex, and more autonomous. Now that we see the big picture, let's look closer at each one. Let's dive deeper into the second layer. What exactly is machine learning, and how does it actually work? Traditionally, if you wanted a computer to do something, you had to write strict, fixed rules. This is traditional programming. But machine learning changes everything. ML enables computers to analyze large datasets, learn hidden patterns automatically, and make predictions or decisions completely on their own. Instead of writing thousands of lines of fixed code, developers simply provide the data. The machine studies that data, learns the hidden patterns, and discovers the rules on its own. You use machine learning every single day without even realizing it. When your email automatically filters out spam, that's machine learning. When Amazon or Netflix recommends something you might like, that's machine learning. And when your bank detects a suspicious credit card transaction and alerts you to possible fraud, that's machine learning, working quietly, behind the scenes. In short, machine learning turns computers into pattern recognition engines, using structured data to make our daily digital experiences smarter and faster. Now let's step into the innermost circle. What is deep learning, and why is it creating such a massive buzz in the tech world today? Deep learning is an advanced form of machine learning that is inspired by the structure of the human brain. It uses artificial neural networks with many hidden layers to automatically process and learn complex patterns from massive amounts of data. Think of it like an assembly line of digital neurons. The first layer looks directly at raw data streams. The middle layers slowly break down the complexities. And the final layer, finally, delivers the output. Because it can handle incredibly messy, unstructured data, deep learning powers the most advanced technologies on Earth. It is the driving engine behind modern conversational chatbots like ChatGPT and Google Gemini. It enables computers to master image recognition and speech recognition with human-like accuracy. And it is the core essential technology allowing self-driving cars to safely navigate complex, unpredictable city streets in real time. While simple machine learning excels with clean numbers, deep learning is built to understand the chaotic world of human language, sight, and sound. We've looked at both, but let's break down the single biggest difference between machine learning and deep learning: how they extract features. In traditional machine learning, a human data scientist has to do the heavy lifting first. The human must manually study the raw data and extract the specific, structured features for the model. For example, to catch a spam email, a human engineer must specifically tell the model to look at the number of links, check for spam words, or evaluate the sender's reputation. The model then uses those human-selected features to make a simple prediction. Deep learning works very differently. Instead of relying on a human to define the important features, we simply provide massive amounts of raw, unstructured data. For example, thousands of cat images. The deep neural network then learns everything automatically. No one tells it what to look for. At first, the network learns to detect simple edges. Then, it combines those edges to recognize shapes. As learning continues, it identifies more detailed features, like eyes, ears, and fur patterns. Finally, it puts everything together and correctly recognizes the cat. Now, remember the most important difference. Machine learning depends on humans to select the important features. Deep learning discovers those features automatically by learning directly from the data. That's why deep learning is so effective for complex tasks, such as image recognition, speech recognition, and today's powerful AI systems, including large language models. If deep learning is so powerful, why don't we use it for everything? The answer comes down to one important factor: scale. Let's see what happens as we give both technologies more and more data. Traditional machine learning performs extremely well when working with small to medium-sized datasets. It can achieve excellent accuracy with relatively little data. But now, look at the green curve. As we continue adding more data, its performance starts to level off. Eventually, it reaches a plateau. At that point, adding even more data doesn't significantly improve the model. It has learned almost everything it can from that approach. In other words, after a certain point, more data doesn't make a traditional machine learning model much smarter. Now, look at the purple curve. This represents deep learning. At first, when only a small amount of data is available, deep learning doesn't perform very well. In fact, it can be less efficient than traditional machine learning. But watch what happens as the amount of data keeps growing, more and more and more. As the dataset becomes massive, the deep learning model continues to improve. Its accuracy rises dramatically. Eventually, it pulls far ahead of traditional machine learning. This is where deep learning truly shines. So what's the key takeaway? It's actually very simple. If your data is small, well-organized, and structured, traditional machine learning is usually the best choice. It's faster, more efficient, and requires fewer computing resources. But if you have a massive amount of raw data, such as millions of images, hours of speech recordings, or billions of words, deep learning becomes the clear winner. It's the technology behind today's most advanced AI systems, delivering the state-of-the-art accuracy that powers applications like image recognition, speech recognition, and large language models such as ChatGPT. There's one more important difference that we need to consider before building an AI model. It's not just about the data, it's also about hardware and training time. Let's start with traditional machine learning. Most machine learning models work with smaller, well-structured datasets. Because of that, a standard computer, using only its CPU, is often more than enough. You usually don't need expensive hardware. Training is also surprisingly fast. You load your data, choose your model, click Run. In many cases, the model finishes training in just a few minutes. Sometimes, it takes only seconds. That speed makes machine learning an excellent choice for many real-world business applications, especially when the dataset isn't enormous and quick results are important. Deep learning is a completely different story. It is incredibly powerful, but it also demands far more computing power. Why? Because deep learning processes massive amounts of raw data through millions or even billions of connected neural network parameters. A standard computer CPU simply isn't designed for that kind of workload. Training a large deep learning model using only a CPU would be painfully slow. Instead, deep learning relies on powerful GPUs. Graphics processing units can perform thousands of mathematical calculations at the same time. This parallel processing is what makes deep learning practical. Even with high-end GPUs, training isn't instant. Depending on the size of the model, it may take hours, days, or even weeks to finish training. So, which one should you choose? If you need a fast, cost-effective solution that runs on standard hardware, machine learning is usually the better choice. But if you're willing to invest more computing power, more time, and more resources to achieve the highest possible accuracy, then deep learning is the right solution. Choose the tool that best fits your data, your budget, and your problem. Deep learning is incredibly powerful. But what makes AI tools like ChatGPT, Google Gemini, and Claude feel so surprisingly human? The answer lies in a major breakthrough called the transformer architecture. This technology completely changed the future of artificial intelligence. Before transformers, AI models processed text one word at a time. As each new word arrived, they gradually forgot what appeared earlier in the sentence. This made it difficult to understand long conversations or complex ideas. Transformers changed everything. Instead of reading words one by one, they can look at the entire sentence all at once. They understand how every word relates to every other word. Now, let's take a closer look at how a transformer processes your input text. You'll see why this architecture became the foundation of modern AI systems, including ChatGPT, Gemini, and Claude. So, what actually happens when you type a prompt? The moment you enter your question, the text is processed by a series of powerful, Self-attention layers. These layers allow the AI to look at the entire sentence at the same time, not just one word after another. It understands how every word is connected to every other word, even if those words are far apart in the sentence. Once the AI understands the full context, the information moves through multiple layers of neural networks. Each layer extracts more meaning. It refines the context, understands your intent, and prepares the best possible response. Finally, the model generates clear, natural, and meaningful text, one word at a time. This is the technology that powers today's most advanced AI assistants. Without the transformer architecture, tools like ChatGPT, Google Gemini, and Claude simply wouldn't exist. It represents the cutting edge of modern deep learning, and it is one of the biggest breakthroughs in the history of artificial intelligence. We've covered a lot of information. Now, let's bring everything together with one final comparison. This table summarizes the key differences between machine learning and deep learning. Let's begin with the learning method. In machine learning, humans must manually identify and select the important features before training the model. Deep learning takes a different approach. It automatically discovers and learns those features directly from the data. No manual feature engineering is required. Next, let's look at data requirements. Machine learning works best with small, well-organized, and structured datasets. It can produce excellent results without requiring enormous amounts of data. Deep learning is different. It performs best when it has access to massive amounts of raw data. The more high-quality data it receives, the better it can learn, and the more accurate its predictions become. Now, let's compare training time and hardware requirements. Machine learning is fast. It can usually be trained on a standard computer, using only a CPU. For many applications, that's all you need. Deep learning is much more demanding. It requires powerful GPUs to process enormous amounts of data and perform millions of mathematical calculations at the same time. Training also takes much longer. Instead of seconds or minutes, it may take hours, days, or even weeks to complete. Finally, let's talk about accuracy. Machine learning provides reliable and accurate results for many everyday prediction and classification tasks. Deep learning takes accuracy to another level. For complex problems, such as image recognition, speech recognition, natural language processing, and generative AI, it delivers state-of-the-art performance. So, here's a simple rule to remember. If you have a smaller dataset and a straightforward prediction task, choose machine learning. But if you're working with images, audio, video, large amounts of text, or building modern AI applications, choose deep learning. Now you understand the core differences between machine learning and deep learning. These technologies are shaping the future of artificial intelligence. Deep learning is incredibly powerful. But how is it different from traditional machine learning? Let's compare them side by side. Let's start with machine learning. A human expert first studies the data, then they manually select the most important features. For example, when building a spam email detector, the engineer might choose features like the number of links, spam-related keywords, or the sender's reputation. These carefully selected features are then passed to a machine learning model. The model learns from those features and makes predictions. Now, look at deep learning. There is no need to manually select features. Instead, we provide massive amounts of raw data. For example, thousands of cat images. The neural network learns everything by itself. It first detects simple patterns, like edges. Then, it combines those edges into shapes. As learning continues, it recognizes more detailed features, like eyes, ears, and fur patterns. Finally, it combines all of that information to recognize the complete object. In this case, a cat. So, what is the biggest difference? Machine learning depends on humans to identify the important features. Deep learning discovers those features automatically. It learns directly from the raw data. That's why machine learning works best with structured datasets, while deep learning excels when working with massive amounts of raw data. Remember this simple rule. Machine learning learns from human-selected features. Deep learning learns the features by itself. And that's the core difference between machine learning and deep learning.